11th week of digital distance learning. This week we are going to talk about perimeter and area beyond the rectangles and triangles which we did last week. Remember, squares are a special type of rectangle, so rectangles and triangles from the previous video, and we are going to move on to parallelograms, trapezoids, and circles this week. If you have any questions, feel free to reach out to me or come to office hours. You can also sign up for an individual meeting. And remember that you need a piece of paper and a pencil so you can take notes during this video and take a picture of them at the end to submit it in Google Classroom to get all your points. You also need this blue piece of paper. If you do not have it, I have left a digital copy right here on the link to this video so you can have access to it as well. Just like last week, we are going to have a basic and an expert level so you can choose which level is appropriate for you. If you are watching one video, you feel like it is too difficult or too easy, you are always welcome to switch to another level, and we will actually get to practice. Since last week we had the benchmark, since last week we had the benchmark, we didn't get to do as much work as I was hoping we would, but don't worry, we get to make up for it this week. Talk to you soon. This is a parallelogram. It is a figure with two sets of parallel sides, the bottom and the top as well as the left and the right. When we draw those parallel lines, we see a transversal crossing through it, so those same side interior angles are supplementary and opposite interior angles are congruent. We have two sets of congruent sides in each parallelogram. We have been given the perimeter to be 14.54 units, with two unknown sides, value of x, and two known sides, value of 5. We can create an equation to solve for x. With the perimeter at 14.54, I can replace p with this value, add 1x plus 1x, which is 2x, and 5 plus 5, which is 10. When I subtract 10 on both sides, I am left with 4.54 is equal to 2x. If you are subtracting by hand, please remember to put the 0.00 so you can actually subtract properly and not write 14.44. Let's divide by 2 on both sides, and our final answer is x is equal to 2.27. Let's consider the area of this parallelogram with base 5 and height 4. Notice that the height cannot be 2.27 as it does not create a right angle with the ground. The area is therefore 5 units multiplied by 4 units. We do not know what the units are and you do not have to write them down, but I want to show you what happens when we do. 5 times 4 is 20, and units times units is units squared. This is the reason area has squared units. You can also picture this with the letter U for units. It's the same thing as x times x equals x squared. Therefore, our units for area are always squared. Did you ever notice how the formula for the area of a parallelogram is almost identical to the formula for the area of a rectangle? That is because a rectangle is a special type of parallelogram. It just has 4 right angles. If you take a parallelogram, any parallelogram, and cut a straight line forming a 90-degree angle with the ground, you are separating this parallelogram into a triangle and a trapezoid, and move it to the opposite side, you can form a rectangle. That is how we know that rectangles are a special type of parallelogram. We are given that the area of this trapezoid is 36 square meters, and we have to find the height, which we know is this vertical line because it makes a 90-degree angle with the base, with both bases actually, since they are parallel. Now the formula area for a trapezoid is area is equal to 1/2 the height times base 1 plus base 2, where the height is unknown, but my bases are 4 and 8. I can also say that my bases are 8 and 4. They are interchangeable. Now I can plug in my values. My area is 36, and I am going to include my units here. 1/2 does not change because it is part of the formula, and the height, we don't know the value, but we do know that it is meters. We also know that we have one base is 4 meters and another one 8 meters. You do not have to write the units when you solve, but I want to write them just to show you what happens when we do. I'm going to copy down the information I cannot solve and work towards that parentheses. 4 plus 8, or 4 meters plus 8 meters, is 12 meters. Next, I can deal with the 1/2, which I know is divide by 2. I can say 12 divided by 2 is 6, or 12 meters divided by 2 is 6 meters, and multiply that by the height in meters. Now, to isolate that variable, that h, I am going to divide by 6, in this case 6 meters, and that leaves me with h meters. Now 36 divided by 6 is 6, and m squared divided by m is the same as saying m times m divided by m. When we cancel one of the m's on top and one of the m's on the bottom, we are left with 6m is the height in meters. 6 meters is my height. To find the perimeter, I can simply add 4 plus 7 plus 8 plus 6, and that gives me 4 plus 7, which is 11, plus 8, which is 19, plus 6, 25. Of course, that is 25 meters because each of these units were in meters. This isosceles trapezoid has congruent non-parallel sides. Both of these are 25 centimeters, but this is not drawn to scale, which means this figure is not accurate. Trust the numbers, not the image. Now I have to find the area, and I can use some of this information to get there. But wait a minute, 5 inches, 25 centimeters, 10 inches, 25 centimeters, inches and centimeters, even the height is mixed. We need to get all the same units, and in order to do that, we are going to look at the conversion part of our reference sheet, which says that 1 inch is equal to 2.54 centimeters. To convert 5 inches, I can create a proportion where inches are under inches and x centimeters, the unknown, is under centimeters, and I can now cross multiply. 1 inch times x centimeters is x centimeters times inches. You do not have to have your units, but you can. And 2.54 centimeters times 5 inches is 12.7 centimeters times inches. Now to remove the inches, because we want our answer in centimeters, we can divide and cancel them out, leaving us with x in centimeters is equal to 12.7 centimeters. And that is our base 1. So we can replace 5 for 12.7. We have one more value that is in inches, the 10. So let's go ahead and create a proportion for that. 1 inch is equal to 2.54 centimeters, and we are going to put 10 inches under the 1. Now we can say 1 times x is 1x, and 2.54 times 10 is 25.4. To cancel out the inches, we can divide them on both sides, and we are left with our answer in centimeters. So our second base, 10 inches, is 25.4 centimeters. And now we can figure out what the area is. The area is 1/2 the height times base 1 plus base 2. Well, we know the height is 20, and we know what our bases are. Base 2 is 25.4 and base 1 is 12.7, or the other way around. Remember, the height must be at a 90-degree angle with the ground. It should not be at an incline. Area is equal to 1/2 the height, which is 20 centimeters, times base 1 plus base 2. Again, if the centimeters are confusing for you, you do not have to include them. Now 1/2 of 20 is 10, of course, and 12.7 plus 25.4 is 38.1. Now I multiply 10 times 38.1, which is the same as saying 38.1 times 10 to the first power. Do you remember scientific notation from semester 1? Well, it should come in very handy. 381 centimeters square, or in English, square centimeters. The area of the circle is 25 pi square feet. We have to find the radius, which is x, as well as the diameter, which cuts the circle in half along the center point. Now let's take a look here. The area is equal to pi r squared, where area is 25 pi square feet, and pi r squared can just be copied down. Because I want to take into account my units, I am going to erase the square and put r feet and then square that. You do not have to do units, but again, it's helpful to look at what happens with them. Now let's cancel out that pi. Because we have pi on both sides, we can just divide it and cancel it out, leaving us with 25 square feet is equal to r feet squared. When we have a square, in order to get rid of it, what we want to do is take the square root of both sides. Well, the square root of a square cancels out, leaving me with r in feet. Meanwhile, the square root of 25 is 5, and feet squared, again, cancel out the square and are left with feet. So r in feet is equal to 5 feet. For the diameter, we know it is the radius times 2, so I am going to write 10 feet. If this is really confusing for you, please go back to the basic level where we talk a little bit more about each of these terms. Now for the circumference, we have 2 pi r, which is 2 pi 5, and there's no signs here, so we are multiplying. 2 times 5 is 10, and pi comes down, 10 pi feet. We remember that the C stands for circumference, which is the perimeter of a circle. We do not use the word perimeter because perimeter requires sides and circles do not have any sides. We can also multiply this to get 10 times 3.14, which is 10 to the first power, and that means we move the decimal over 1 time, 31.4 feet. Both answers would be correct. In this circle, we are given that the circumference is 20 pi units. Because I am given circumference, I am going to look for my circumference formula, which is 2 pi r, and replace the circumference with 20 pi units, or u. On the side of 2 pi r, I don't have any information yet, except that the radius will be in units. So I'm going to put my u there already. I can divide 2 pi on both sides. Notice I could divide just pi, but also 2 pi. Since I will have to divide both to cancel them out. And 20 divided by 2 is 10, so 10 units is equal to the radius in units. Now, because the radius is half of the diameter, I can say 2 times 10 to get my diameter of 20. And to find the area, well, I simply have to plug in my values. Area is equal to pi r squared, which is equal to pi times 10 squared, and 10 squared is 100. 100 pi square units. I can of course notice that if this is units on the 10, I would have to say units squared. And 100 times pi is the same as saying 10 squared times pi, so scientific notation tells us to move the decimal over 2 times. My final answer is 100 pi square units, or 314 square units. A composite figure is made up of many different shapes. Here we have a semicircle. It is half of a circle with diameter 7. Let's find the area of the semicircle. Pi r squared becomes pi times 3.5 squared because the diameter is 2 times the radius. And 3.5 squared is 12.25. I bring down pi and notice that I have to divide by 2. That is because I only have half of my circle. This is 6.125 pi square units. In order to multiply this, I can say 6.125 times 3.14, and I am left with 19.2 square units. It is important to not leave pi here, as it will help us finish the answer better when we have different types of figures. But there is another circle, or at least a part of a circle, with a radius of 3. Well, let's find our area. Area equals pi r squared again, where pi times 3 squared is the same as 9 pi, or pi times 9. We definitely want to multiply by pi, so we have an answer with decimals, and 3.14 times 9 is 28.26 square units. However, I do not have the whole circle. In fact, I only have 1/4 of the circle, so I am going to divide by 4. Break this into 4 equal pieces. 28.26 divided by 4 is 7.065 square units. You may be asking, can I just round? Yes, you can. However, it's nice to have some decimals just to get close to an exact answer. Moving on to this trapezoid, we see that the height is 3 because we have some congruent sides, and we have 2 bases. Base 1 is 7 and base 2 is 9, or the other way around. Well, let's plug in our values. Area is equal to 1/2 the height, which is 3, times the 2 bases, 7 plus 9. And 7 plus 9 is 16. Now I can think of multiplying or dividing first, and I'm going to divide because 16 divided by 2 is an easy 8, and 8 times 3 is 24. You could also multiply first and then divide at the end. Both options would be correct. You'll get 24 square units. Finally, for our rectangle, we have 3 by 9 rectangle. This rectangle has length 9 and width 3, or the other way around. It's not really important which one you label which, because 3 times 9 and 9 times 3 are both 27 square units. Now we have found all of the different parts of our composite figure. In order to find the area, we simply add all the values. 19.2 plus 7.065 plus 24 plus 27. Notice that if you add, you have to place the decimal points over the decimal points. 5, 6, 2, and 9 plus 7 plus 4 plus 7 is 27. I carry the 2. 2 plus 2 plus 1 plus 2 is 7. For this composite figure, we are asked to find the shaded region. The shaded region means the grayed out area. Notice this is like a window screen with a parallelogram taken out. Let's find out the area of the big figure, the square. Area is equal to s squared, and in this case, area is going to be equal to x squared square units. Because the side is x and we do not know the exact value. Now let's find the area of the parallelogram in the middle. We know it is 1/2 x for the base and 1/3 x for the height. I know it's a little bit difficult to see on the picture, but 1/2 x for the base and 1/3 x for the height. Knowing that, area is equal to base times height, or length times width, we know it's the same, where the base is 1/2 x and the height 1/3 x. Now, x times x is x squared. That should be pretty easy. Do not get nervous about the fractions. We multiply the numerator, 1 times 1, and the denominator, 2 times 3. 1 times 1 is 1, and 2 times 3 is 6. 1/6 of x squared square units. Now that we have both areas, we can take a look at the shaded region. It is everything on the square minus the parallelogram. We take out a window from this screen. And so we are going to do x squared minus 1/6 of x squared. And 1/6, we can think about it as a pizza. You take out one slice. Well, x squared would be 1x squared. It would be the entire pizza, one whole pizza, which is the same as thinking about 1 or 6/6. 6 slices of 6 total in the pizza. If I take out 1/6, then I am left with 5/6 of x squared. My final answer is 5/6 x squared square units.